Alright, so as you can see, I've written 3 problems on the board. These 3 problems are something simplistic and easy until you get to the last one. It's yet again time to add some information to you and show you one of my lovely little tricks. In this, you will need a periodic table. I'm throwing mine up over on the ViewSonic if you want to see it. We're going to start rolling through these. Listen to me. When they call the juniors out for your meeting, go to your meeting. I'm going to keep going.
Oh,
Seniors, when you get called out, go to your meeting. I'm going to keep going.
Why would you do that?
Because I'm recording it right now. So in this, you literally get to see this. Now, I've already thrown out some videos out there. I threw out a video from you all, from the lesson I did with you guys, second period. On those mole calculations, I did a really complex problem. Guess what? I did a different one in 5th period. You need to watch both videos. Okay? We're hitting crunch time right now, ladies and gentlemen. We are hitting crunch time. So we're going to start with this first one here. How many moles are in 78.3 grams of methane? That's this CH4, okay? CH4. So in this, what is my starting point? Grams. So I'm starting with mass. What's the key whenever you're starting with a mass? What does it have to be in?
Grams.
Grams. Am I in grams?
Yes.
Hallelujah. This problem's not got a trick in it yet. How many moles? What's the end point?
Moles.
Moles. So it's a one step. It's nothing complex about this one. So it's pretty much simplistic in this, that you're going to set it up with the number 78.3 grams of methane over 1. Set the conversion factor up. I want moles. What goes on the top? 1. And what's the units? Moles. Number 1 goes with it because moles are number 1. Remember that. In the bottom, I'm needing grams to cancel, so I have grams of methane. But where do I get that from? Where's this blank come from?
The column.
Is methane an element?
No.
No, there's 2 elements in there. So we must find the molecular mass. Yes. So in this, you write down the elements you got. We did this already, but so you write it down. I got carbon, and I have hydrogen. Write down next to it the number of them that you have. There's no number here, so it's just like in math. There's not a number there, which means it's 1. So carbon we have 1 carbon, and there's a 4 next to the hydrogen, means there's 4 hydrogens. You're going to multiply that off their average atomic mass, which you get from the periodic table. Whoa, we're zoomed in.
Whoa.
So go to carbon. What's the average atomic mass of carbon? 12.011. That's grams per mole. What is the average atomic mass for hydrogen?
1.008.
Grams per mole. 1.008 grams per mole. Pull up my calculator.
Carbon's just going to be 12.
So,
But it will be 16.04.
then we get 4.032 grams per mole. Add these 2 numbers together to give us 16.043 grams per mole. What are what numbers? Which ones? What? All this is, these numbers here. You talking those numbers? So you're talking here? 12.011. And then the bottom one under that is 4.032.
Did you say if it's on the bottom we divide, or if it's on the top we
If they're in opposite spots.
divide?
Yes. So in this, we now have this number. We've calculated the molecular mass, which we found to be 16.043 grams. That follows along with this. The dead giveaway that you're going to have to calculate molecular mass. So when you're dealing with a compound or a molecule, what that is when there is not just one element. There's two elements here. Dead giveaway. Must get molecular mass.
I don't like. I don't want
But if you had only one
I got
other
zero.
element,
I got .00.
You would not.
Yeah,
So in this,
I don't know what I did.
do the operation. When you're finding this, 78.3, I'm going to multiply or divide. So 78.3 is in the numerator here. The 16.043 is in the denominator here. You divide. They're in opposing sides. So divided by 16.043, which gives me 0.06 moles,
Per gram.
not per gram.
Not per.
That's our answer.
Grams of cancer.
Yeah, that's our
That's the
answer.
answer.
Yeah.
What if I was wrong with my calculator?
Appreciate it.
Maybe you just entered it wrong.
So 4.8806 moles of methane. Okay?
So what if you didn't have two elements? Then you wouldn't have to do the adding?
Then you don't have to do the molecular mass. You have to use the average atomic mass.
Oh, you just, okay. Never mind. I got you.
There's the answer. Questions on that one?
Wendy's done.
Huh?
She's done.
She wasn't here when we went over this.
Videos are out there. Never mind. Click on them, find them, come ask me questions. Okay?
He says as we are
We'll work
recording
on
one
the next one.
right now as we speak.
Yes.
So
No questions here.
let me see my notes just for
Okay. Let's go to this next one. I wrote the answer up here so I can erase the answer here, so I got this room to work.
all that hard work.
I know. All right, in this, new problem. How many molecules are in 0.6945 moles of methane?
Alright, so we're at moles already. So we
Look
gotta
at
keep
you!
going.
You got your starting point. You're at moles.
Yeah, we're trying to find
We
moles.
have to go.
Don't we have to go to
follow
grams? So that's a lot
Oh, we
of
have
work.
to use
That's a lot
avocado's number.
So we're looking at molecules. Now this is the
I know
thing, and this
what-
is why I did this. I wanted that question. Do you have to go to grams? Think about it. Where are you at on the mole map?
No.
No, you
I'm
I'm
don't.
right in the center.
Okay.
Do I need to go to grams, which will take me back,
No.
and then have to go back to moles,
No.
and then
No,
over
that's not
They're
moles?
gonna go from moles
No.
straight to moles.
We're going to go straight from moles, straight to molecules. Okay, these are one steps that we broke down. So in this case, write the number that you're starting with, and you guys are going to like these the most.
The moles.
Moles of methane.
Oh.
And this is why you're going to like these the most.
We get
The
to whack
moles.
moles.
My God.
I'm going to use that. It's pretty fun. This is why you're going to like these so much. You don't have to calculate anything.
So that's the kind of
You have to memorize one number. I'm in moles on top. I'm trying to get to molecules. So what goes on top?
one mole.
Molecules go on the top.
Oh, molecules.
Why is molecules on the top? That's where I'm trying to get.
Yeah. And you want the moles to cancel, so the moles stay on the bottom.
So moles go on the bottom.
Are we going to get to use this little table?
Oh snap! We gotta memorize Avogadro's number.
I will give you a clean periodic table to start your quiz on Friday. It'll be the first thing that comes to you. Then from there, yeah.
Yeah, what is
What number goes with the moles?
1.
1, because he is number 1. What number goes with molecules?
6.022 times 10 to the 23rd.
6.022 times 10 to the 23rd. That is Avogadro's number if you do not remember it. So in this,
I actually know that.
it's literally it. No trick. So point 6945. Should we multiply or divide?
Multiply.
Multiply. Why?
Because it's on the top.
They're both in the top. They're on the same side. Times 6.022 second E 23. Which gives me
4.1.
4.182 times 10 to the 23rd molecules.
So that's it.
That's literally it. I told you it would be your favorite one, wasn't it?
Okay, so I don't know what I'm doing wrong, but like you see that it's like 10 to the 23rd. I got
Yes.
to the 24th.
That's
but
what I got.
Let me say you punched it in. So I'm gonna guess you punched it in wrong.
No.
Punched it in wrong. You did times 10 E. Remember that E takes place at the times 10.
It's just times.
So it's you don't even put the times. You just put 6.022 E 23. Okay. Any questions here?
Just a reminder that we do have the fast bus today from 10 to 6. If you need to contact your family and remind them of that, so feel free to come to the office and do so. At this time, we would like to have our juniors report to the auditorium. And
Listen.
the teachers that have juniors, please report them with them at this time. Juniors, report to the auditorium for a brief meeting with them.
Listen to me. I'm putting this video in Remind. You're going to want to go back and watch this video because I'm about to show a trick. That's what they're saying, just juniors. I have class still.
There's 4 people.
They're married, so I
1, 2, 3, 4, 5.
The young seniors
Plus
is
Hannah. You would still probably make the video if there were no people.
Either way.
He's coming to oh my god, you can't do that.
I can't do that. Are y'all ready for this? Y'all have the privilege of getting to see this trick.
Well, let me write it down.
Sadly.
Yeah, let me
So
write
in this, what is the volume of oxygen gas at STP in 68.6 times 10 to the 7th micrograms of oxygen?
Don't start. Let us
I'm gonna let you
put that in liters, don't we? Is that STP?
Trying to get the liters. Yes, it's in STP.
So we wouldn't put it in liters, we're trying to get the liters.
Yes. What have I started you with?
Milk grams. Is that a is milk?
New. It's micro. Okay. So you found your starting point. In this, I love to do this. People hate me for it, but it's one of my favorite things to do. I'm laying a trick within a trick.
So
Because you're going to catch the first trick, which is right here in your units.
first, would you just like do the problems from like the beginning, like kind of like work it out the long way?
Are you talking?
So would you start at grams and go?
You're going to start at grams. There's a trick there.
We have new or whatever.
I have micro. New.
Whatever.
Is that in grams?
Yes. Oh, so you would just have to
Micrograms. You have to.
cancel out the micro
You have to get it from micro
to
grams.
grams.
That's the first trick, and I do this on purpose because there's another trick like here that you have not seen yet. So there's your starting point. Find your end point. You already said it. I think you said it. Okay. We're trying to get to volume of oxygen. What's the units going to be on that?
Hold on. Volumes of. It'd be liters per mole.
Just liters.
Liters.
That liters per mole is your conversion factor.
Okay.
Okay? So we're trying to get to liters. I've laid a trick here. You've never seen this before. And this is when I love to bring these in. You remember how I told you about cubic centimeters? It's going to be one of those tricks that's used throughout the class that I'm going to catch you on. If I don't catch you now, I'll catch you later.
That's where you do the same thing, right?
I'm about to show you another trick that's just like that I will lay throughout this class. And I'm presenting to you right now. And you better memorize it. Super simple. Super easy. Oxygen. Oxygen is special. And this is why oxygen is so special. Oxygen is one of those guys that when we just say oxygen in the air, when you're breathing oxygen in, you're not just breathing O. You're breathing O2. Because oxygen is one of these special things that we call a diatomic. Define it in simplistic terms. That's my goal whenever I'm defining something for you. Diatomic is an element that exists in nature, bonded to itself. There are 7 of these. There are 7 diatomics, and I'm going to show you a trick of how to memorize them. So the 7 diatomics, let's do it this way. Whenever you're trying to find the 7 diatomics, the key to it is use your periodic table. This is why I give you a fresh periodic table on every one. If you're watching the video, close your eyes. This is what you're going to do. They literally make a 7 on the periodic table, except for 1. So your first one that you're dealing with is nitrogen. And it starts and makes a 7. It starts at nitrogen, goes all the way through fluorine, comes down to iodine, or iodine is how I like to call it. It makes a 7 on the periodic table, but that is just 6 of them. The one that's simplistic and easy to get mixed up on is right here, hydrogen. Hydrogen also is a diatomic. What this means is if I'm looking at you and I'm talking and I say oxygen, nitrogen, fluorine, chlorine, bromine, iodine, or hydrogen. When we're talking just about that element, we're talking about them in groups of 2. When we use just their name because they exist in nature bonded to itself. So it never is just O. It's O2. It never is N. It's N2. So if it's by itself, there's 2 of them.
Okay, so they're all going to be like the letters and then 2.
Yeah, like we have oxygen up here. Like I'll write them up here. If you're watching the video, close your eyes. Oops. Got a little carried away. Okay, open your eyes. Alright, so in this first one, I got up here. I went on and wrote oxygen up there. Okay, don't start with the oxygen, start with the nitrogen. So N2. O2, F2, Cl2, Br2, I2, and H2. 1, 2, 3, 4, 5, 6, 7. I'm openly telling you this is a trick because whenever you get to the quiz, you're going to be freaking out. I'll lay a trick, and I literally do this on purpose because you're going to catch this. You're going to look and say, oh, we're micrograms, I got the grams. I got his trick, and you're going to roll on. There's tricks laid in tricks now. You have to catch this with your own eye. But then you also have to catch this, that you're dealing with oxygen. Oxygen special. Oxygen's one of the diatomics. So you're not just dealing with oxygen. You're dealing with O2. Okay? I stress that so that we can now work the problem. So we'll erase all this. All you got to do to catch this trick is to catch that. And I will use this trick throughout the class. It will catch you. So in this, you got to first start with getting this into grams. So I'm just going to write it this way in case somebody needs it. 78.6 times 10 to the 7 micrograms equals how many grams of oxygen, but we're just dealing with pure oxygen, so it's O2.
That's what I mean, like by working it out the wrong way. That's what I meant.
That's what I thought you meant, but I wasn't sure.
And then you looked at me like I was stupid, so I was like, no, that's fine.
I wasn't sure on what you were meaning. I apologize.
I made the same exact thing as her too.
Okay, so in this, we got to get this into grams. So 78.6 times 10 to the something another. First thing you start with, we'll start with that prefix conversion. So we got to go from micro. What's micro?
-6.
-6 minus, what's grams?
We wouldn't use grams, would we? Yeah, we'd have to subtract it and still finish that.
Because there's 2 grams.
No,
So we wouldn't use it, would we?
Grams are the same.
that means the base unit.
So it's, since it's base unit,
It's 0.
0. Which equals -6.
-6 plus
And you're going to add, so plus 7
equals 1.
equals 1, so that's 1. Or in my case, how I'm going to write that, because that's times 10 to the 1, which is 78.6 times 10, I'm going to do 786 grams of O2. And there's my starting point. Now we're going to show you why this is the trick. Write down what you start with. 786 grams of O2. Set it over 1. Set your conversion factor.
So we're trying to get to volume.
Yeah, we're trying to get to volume.
So we'd have liters.
22.4 liters.
What did I tell you about these? What's the key to these? You have to go through it. You're either looking for it, you're starting with it. We call them mole conversions for a reason. What do we go to first?
You would go to mole.
Moles.
Yeah.
So, the moles have got to go on top. And this is where the trick comes in at. Grams of O2 is going to go on the bottom. But this is the thing. When you look on your periodic table, that average atomic mass that's on that periodic table for oxygen is for 1 oxygen. How many oxygens are you dealing with? 2. So you're going to times it by 2. It's like you're making a molecular mass calculations. Juniors, welcome back.
750 times 99 times 2.
So oxygen, 2, times, what was it, 15.39
3 nines equals 31.998. So we put that
That goes in the blank.
in the blank. So then we just work out the problem.
And you work it from there. That's literally the trick. That's it.
4.564.
Oh, you broke it in half. I'm just going to make it one big huge conversion. This one's not a single step. You just took it to moles. Now you're going to have to take that number from moles, set up the conversion factor, that get ready to set up. But you're fine if you want to do it that way, Albert. It's completely fine. All right, so in this, we calculate the molecular mass of that because it's a diatomic. 31.998 grams per mole, so that 31.998 goes there with grams. Now you absolutely can break this in half there. You can do that conversion, get the moles, and then go to liters. But I'm just going to set it up as one big huge conversion. So in this, I'm going to set up my other conversion factor because the grams of O2 is canceled. Now I'm going to set it. I'm trying to find liters of O2. So liters of O2 go on top. And moles of O2 go on the bottom.
22.4.
22.4 go on top. Now this is the key. Why can you make this calculation? You're at standard temperature and pressure, so you can make this calculation. What number goes here with moles? 1. And this is why I like to do it like this. Because now, Aubrey, all you're going to do is that number you got, you're just going to multiply it by 22.4. I like to throw everything in my calculator together.
The number that I got goes on top.
Yes.
I'm gonna do it.
Did you get, I got like,
At this time, we need seniors to report to the auditorium for a brief meeting
What's
with
the
Deputy Toller. If you have a class of all seniors, please escort your students down.
550.2.
That's what I got.
36.
That's what I got. So you get 550.
Take one.
I'm going to write it down here. 0.2344 liters of O2. See, was that hard? It was not hard.
can you do it again?
My juniors! Absolutely. How many of y'all have already started writing this problem? Fantastic. You want me to start from the very beginning?
If you want to.
I recommend start from the very beginning.
Yeah.
So that now that you're in here, and this will be very beneficial because now we get round 2 on the camera.
That's right.
There's something very special here. I'm going to erase all this now so that we're going to start from the beginning. I am this cruel, and I do this with a purpose. I told you, my goal is that nobody in this state will have a chemistry student that can top mine.
Okay.
You will be the best.
Okay.
And to be the best, you must be prepared for every trick out there. And in order to do that, you need to be prepared for tricks within tricks.
Yep. And I feel like one's getting ready to be thrown at me right
Did a lot of circling.
See, you have to make this sound when you're doing this. Yeah.
All right, here's the important thing.
Okay.
Got all this around here. Not a one of you have heard of this yet.
That's right. I have.
You know how I told you cubic centimeters is a trick that will be used throughout this whole class? And if I don't get you now, I will get you later with it.
Yeah.
There is another one of those.
Micro.
Nope. I don't consider that a trick that I'm going to get you with. There is a trick laying within the trick. And the whole reason I lay the trick within the trick is to get you caught off guard. And I'm saying this openly to you right now because you're automatically going to see the first trick. You're going to be like, ha ha, I got you, Mr. Hall. And really, I'm sitting back and I'm going, ha ha, no you don't. You only caught one. There's two tricks laying here.
Yes.
First trick. Do what you've always done. Label your starting point. What are we starting with?
78.6 times 10 to the 7th micrograms of oxygen.
So we're dealing with micrograms of oxygen. Is there a problem here?
Yeah.
What's the problem?
You have to convert to regular grams.
We gotta get grams.
Grams.
That micrograms won't work. You must get to grams.
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 We have to get to grams.
Yep.
That's the first trick that you gotta see,
Yep.
that you gotta catch,
Yep.
that you gotta find.
Yep.
But there's a second trick, and it's so subtle.
The gas.
What is the end point we're looking at?
Volume.
Volume of oxygen. Now, I'll go on and say this. What is the volume? Like, whenever we're talking about volume, what unit of measurement are we looking at?
Liters.
Liters. So we're trying to get to liters. Are you ready for the trick? It's so subtle. There's people I'm openly telling you right now. There are 7 of these. And I will catch you with them. I'm openly telling you they exist. So subtle. It's in the word.
Oxygen. Gen X.
When you're dealing with oxygen,
Yes.
when we say just oxygen,
O2.
it's trick.
O2.
Why is it O2?
I don't know, I just know it's
But
O2.
you have to have 2 oxygen.
Why do you know it's
to make
O2?
one oxygen.
Because you've told us before and just because
I have never told you this.
I've had you as a teacher before. Every time you've ever written
Then
oxygen
why
as
is it
anything, you put it as
H2O2
O2.
when it's water?
It's a molecule. That's peroxide.
I didn't know if it was rubbing alcohol or peroxide.
Oxygen is O2.
I don't know why, I just know.
Today you know why.
Okay.
There are 7 of these beauties.
Wow, the 7 wonders of the world.
Or the 7 diatomics.
Oh.
Don't you just love that word?
Simplistic definition. I'm literally breaking down the whole purpose when I break down the definition so you can understand it. Diatomics is an element that exists in nature bonded to itself.
Not to burst your bubble.
Oh,
There should be an S at the end of it.
Is this an English class?
No, I was just saying not to burst your bubble.
Nah. There are 7 of these. And I'm going to show you the trick to how to know them. It's on your periodic table. If you're watching the video yet again,
Close your eyes.
that's our inner ones.
Or no.
Or rewind.
Yeah, just for
Scrub back the video to the point where we was looking at the periodic table.
And don't forget, close your eyes.
While I'm crying, I'm going to hear Maddie and I'm going to be like, oh my God, if you don't shut up.
What is there so much hate within y'all's class?
Angry.
It's not just, it's not us.
Okay, if y'all want to
It's
hate,
us.
hate me. Stop hating everyone else.
We hate people who have
7 diatomics. Here's the trick. They literally make a 7 on your periodic table except for one of them. Here it goes. You start. I probably should not choose blue since those are blue.
Yeah, probably.
You start at nitrogen. It goes from nitrogen to oxygen to fluorine, and then it goes down to chlorine, bromine, and iodine. It makes the number 7. But if you can count, which if you're in this class, I pray you can,
Nope.
you can get to 6. Here's the one that's all by itself.
Hey, you showing us on the camera?
It's on the camera. I did it before with the seniors. Hydrogen is a diatomic, which means it exists in nature bonded to itself. So within this, there's 7 of them. You go into O2, F2, Cl2, Br2, I2, and H2. These are your 7 diatomics.
Once you learn them, don't forget them.
It's all fair game.
Yep.
Tell my kids if they want to see y'all like fall on the floor and start convulsing and shaking, to say that first line to you.
What first one?
Once you learn it, don't forget it. So this is the thing. You have to memorize these. I gave you the trick to how to memorize them. They will come back to play in this class. I personally promise you and guarantee you, if I don't catch you with it now, I'm going to catch you later.
Hush.
You best be prepared. So now we got to erase this so we can start working on this problem.
Yeah.
So in this, we discovered the first trick. I'm going to write it like this in case you need to see it. 78.6, sorry, jumped the gun, times 10 to the 7th micrograms equals how many grams?
786 of them.
Huh?
So we're going to break it down. Write the number down.
-6.
78.6 times 10 to the something another. So you look at what's the same? Grams. What's first prefix? Micro, which is new, which is what? -6 minus
0.
because gram is the base unit. So -6 plus what you start with, which is 7, gives you 1. So the number is 1. In this case, I don't feel like having to type that into a calculator, but I can just look and say 10 to the 1 is 10. 78.6 times 10 is 786 grams of O2. Start like you always have. 786 grams of O2. Set it over 1. We'll set the first conversion factor. Now we're trying to get the liters. Don't get tricked up here. You're trying to get the liters. The first thing you're going to be looking at having to do is getting into moles. If you can't get it to moles, you're not going to be successful. There's a reason we call them mole conversions. So we're looking for moles of O2. So 1 mole of O2. And this is where the trick lies that you will mess up. This is O2. On your periodic table, that average atomic mass is for 1 oxygen. So when you do this calculation to find out what number goes with grams of O2, you have to look and act as if you're calculating an average atomic mass. Oxygen, I have 2 of them, times 15.999 grams per mole equals
31.998.
Let me change the color marker so it pops out to you.
That's important.
31.998 grams per mole. So 31.998 grams goes there. Now from here you're not done. You can put stuff up and go whenever you feel like you need to. I'm going to finish this problem.
Heck yeah.
Grams of O2 is canceling out. Now you're going to look at this. Set up another conversion factor because you're looking for volume, which is liters. So whenever you look at this, yes, I'm going a little faster so we can get through this. Liters of O2.
22.2.
And on the bottom, you have moles of O2. Now, 22.4 goes here, but why can you do this calculation? What gives you the ability? Thank you, Seth. We're at standard temperature and pressure, which means you can make that calculation. So, moles of O2 will cancel. You punch this all in your calculator, and you end up getting 550. That's a horrible 5.2344 liters of O2. There's your tricks. That's where it lies. I literally don't think I have any more tricks to show you besides I can just put a bunch of them together. If you have questions, come see me. Have a fantastic and wonderful day.